Hello, hi, and I hope you can see the setup here. Maybe this the whole screen should be available, should be visible. Whole screen is visible. I should have spoken to YouTube. This is okay. This is okay. Yeah, this is. So if I'm going to be all right, so this is a shadow. All right, this is just a shadow. The easel is not quite right. So all right, my last video I spoke about collapsing of waves, the um, 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 Niels Bohr, collapsing of waves by there was the Everett interpretation, and then I dealt with the Copenhagen interpretation. And interestingly enough, that I kept at it. All right, so I came out with the exact dimensions of the RNA molecule, not all of it, but by analyzing, by analogizing with the DNA molecule, because if it had the properties of the DNA molecule, then the RNA molecule is also a double helical structure. So that is what I reached with the Niels Bohr and the Werner Heisenberg matrix setup. All right, so my setting up, I had shown you a bunch of differential calculus workout, so the position momentum in the matrix, and then with the identity vector is equal to the eigen value and the identity vector again. So so that, and then I assume correctly wherever it was necessary, either so psi1 del psi2 by del t is a minus del psi2 multiplied by del psi 1 by del t is equal to 0, or is equal to the eigenfunction lambda. So that way I got the right values, and the RNA is a double helical structure. So quite a bit of values, and then I thought psi3. So I made 2 dishes that night with veggies. So you had to go down to the quantum level of micro mixing. So you had to blend it. So all my secret recipes I'm not giving away. All right. So one was a Toronto snack, awesome Toronto snack. Trick is to blend the carrot, all right, chopped carrot. The rest I'm keeping secret, but I had a chili and some, chopped onions in. But chopped onions are not going to come in, all right, because I think I added a few cilantro pieces, and the other one was the famous chickpeas, the chole. And for that, some of it I blended in. So, I had 4 to 5, 6 different types of veggies in there. And so that gave me more values. But I have to thank Google for guiding me along in the right path. All right, so they gave me, when I looked up the what had I made, the coconut macarons. So they gave me the formula for 2 measurements I got, but I had set up the equation correctly. So together, so this is like a symbiotic process with Google here. So the rest, I they should adapt my research as possible, findings, and give me publicity. Who knows? But in my newspaper, the Globe and Mail, that would be something. So now I'm going to see X-ray diffraction. So the method. All right, so that actually requires analytical equipment. That's what the famous pair, Crick and Watson, had, and they analyzed, and then of course the controversial Rosalind Franklin photographs, etc. So the X-ray diffraction. So X-ray diffraction analysis requires X-rays. So I am going to use this electronics kit. You may have been familiar. You may be familiar with this from back to my career, Busland cameras. So use this, and then set up X-rays. So X-rays. So that took a while, because my all my electronics papers on my LinkedIn webpage, that's been a while back. So I've lost my edge, etc. But then I focused and I thought and I came out with it. So, and then this kit is also not familiar, but now I had all these things I would do with semiconductors and diode transistors and diodes. Semiconductors are diodes and transistors, and the LEDs and LED diodes. But I cannot, or LED diodes again. I'm double saying the same thing. Light emitting diode LEDs, but I'm resorting to batteries, comfortable double A batteries this time. Energizer. It's going to get me the right answer. So what is the setup is that, so I'm going to generate X-rays. All right. So it's a bit of getting a worked out solution, which I'll share with you, and then set up the circuit, and then pass it through Swarovski crystal. This is a Swarovski crystal pen or a regular crystal vase. And the other things I have is a Swarovski crystal pair of earrings and a regular crystal scotch glasses. Not right for research, right? Having in the night enjoying a bit of scotch or wine or any or sherry even is done, but not when experimenting. So maybe not, but if it could be a better result, I might just scoot across to the other room and get the scotch glasses and maybe the Swarovski crystal earrings. So Swarovski, so the X-rays pass through the Swarovski crystal, and then the samples. So I have spinach here, I have carrots here, I have tomatoes here, and so I beg your pardon. So, and then that makes a pattern. And I have no idea what pattern I'm looking for because James Watson in his book has not shared what pattern actually comes onto the screen. All right. So, let's see what comes up. Okay. So once I had done the same setup outdoors, and I got light as waves. So that's on my LinkedIn webpage, and I've shot a picture of it. But either maybe but the picture was not as distinct as when I saw it, shot the picture. Maybe the camera effect and shadows and things like that, they don't do well. So so shadows seem to be doing well here. So let's see. So what is in the? I'm going to pull out my file and what is in the so the setup. So I took E equals H nu, MC square, etc. I square R, and P equals energy by time. The rest all is on the internet. So taking it to it, I got the setup to be all right. So this is equal. So first capacitor. So I'm going to be first taking out a capacitor. And now, I've forgotten the set completely. Capacitor, resistors, capacitor. Does it say capacitor? Looks. Oh, they have batteries here too. So this is set. This is a close-up view. Capacitor, alligator clips. These I'm not taking these out. So these are, I guess, semiconductor transistors or something. Oops, nobody has actually accessed. Okay, so wires. So black is always negative. Black is always negative. So this might be good. So I'll just write this down and then come back to the page more. So so 5 picofarad, 5 picofarad, microfarad, 10 millihenry square. So 2 square, 2 star 4 batteries because it's di by dt whole square, and plus 3600 a resistor. So plus 2.2 what ohms is this? 2.2 kilo ohms. So I needed 3600. So I'll just make this correction in a big quick while. Kilo ohms, kilo ohms, save, and let me just close this and come back to the camera, and then set up 5 pico. So that's all is the setup. All right, it's going to generate X-rays, and I took an average. X-rays again range from 10 power 16 to 10 power 19 um, frequency. Right, I'm looking at frequency, hertz. Cycles per second. So 3 multiplied by 10 power 18. So was the average. So that's what I'm looking for. So this might be better, right? For 4 batteries. This might be a shorter because these are long wires. And this is, this is, this is, I've lost my edge. I could do this really well. So alligator clips. These are alligator clips. These are alligator clips. So so that might be good. This is so this is all this way. This is a resistor, I think. This is a resistor. It's giving temperature. So what could be giving temperature? So this this is a glass. The easel wouldn't work because it's at a higher up range. Somebody calls up when I'm busy all the time. Easel, this is no good. So this is of course a painting of mine, a close-up view. I'm getting all distraught, upset. So this is a nice change. And then, okay, this is yeah. So so this connects the batteries. These are the diodes, I think. These are the diodes. Wow, it's really poorly done. It's 100, and they gave me free shipping also. But these are the LED diodes. Those are the alligator clips. I need just one capacitor. One capacitor. So and 10 milliamp. It doesn't say on top. But if you're an electronics student, you would know all these things. So this has been a hard sort of exercise for me, personally speaking. These are resistors, I think. Jade, these are resistors. So, so this number 2220, where does it say? This 2.2 picofarad, 5 picofarad, 205010. Mixed it all up. This is not going very well, but experiments have to be done with a cool head. Uh, these are LED lights. This is this has the terminal, battery terminal. So so this is 0.58 ohms. How many ohms do I want? 2.2 kilo ohms. So this is 8 ohm resistor. So I've used a capacitor. Wait, let me see capacitors and pictures. All right. Let's see if Google in and symbols. Okay, so this is a capacitor. So it's a capacitors and condensed symbols. So this is a capacitor. Okay, so this is a capacitor. Symbols, I don't know. So capacitors are alligator clips. Oh, 100 microfarad. Well, they didn't look like this at all. These are capacitors, 500 microfarads. So these are capacitors and 5 picofarad, 100 micro. Maybe I need to connect all of these. This is not going well. This is 100, so 5 picofarad, 100 mic 33. Oh, millihenry. There we go. We have a inductor, millihenry. Millihenry. Oh, I need to improvise. 10, I needed 10 millihenries square. Um, two inductance in inductance is square. 10 millihenry square. Let's see. I had picked up to subtract and everything, what to connect. That it was going so well for me, but I'm not even qualified in electronics. So I guess, a few friends whom I spoke to said, just let it go. I mean, this is not your area. So this is 100, 100 microfarad. So would this be two twin, right? Would this be two, you think? We will just ask Google. This is a capacitor. A capacitor with two little cylinders, each labeled 100 microfarad is equal to there are 200 microfarad. Oh, this is twice itself. Oh, I have forgotten this. This is twice itself. So 100. So this is 200 microfarad. So this is connected in parallel, isn't it? The two of them together, not in series. So this is 5 picofarad. This is it's fading also. It's becoming old. 5 picofarad. 122 amps. But we'll just do the batteries because I have to think it out. Has somebody stolen these? This is 40 to 105 degrees centigrade. This is one. 470 microfarad. 470 microfarad. So these are connected. So 470 twice 470 is, I need to go to 10 power minus 12 microfarad. So is 200 microfarad. Oh, this is rather hard. Where is my 5 picofarad? 5 picofarad. Getting only micros. 1000 microfarad. Oh, this is small because micro is 10 power minus 6. Oh, this is rather hard. I don't have the right. If somebody has stolen or he's not given me what he said he's given. This is. But I thought I did really well. I should set up the circuit, right? Should set up the circuit and come on and connect it to my YouTube camera. Picofarad, 1 picofarad. There's no picofarad at all. There's only microfarad. Oh, these are too small. So this is a resistor. What is this? We will see. There's no picofarad at all. He doesn't have picofarads. He just said, so there's no picofarad. So how about I ask Google if I have parallel, so that's 200. I have to generate more current, won't I? But 10 power. This is not going well. This is. I thought I had it. What are these? Somebody has stolen, I think. Somebody has stolen from me. This is, what is this? Choke I have, 33 millihenry. Quickly, how about I go to my calculator? A picofarad, disc, this is the disc. Oh, this is picofarad. Disc, so this is the only disc. Disc, 550 volts, 10%. So this is the disc. Looks like a disc, right? So this is the disc. Picofarad. numbers there. 2n 3130 SS. 2n30 SS. 2n 3055. 2n3055 is 2n3. There are only twos. Fast. Please put up with me. All right. Please put up with me. I'm going to be there, and maybe we generate the together. We are in this together. All right. Generating the. Sorry, we have replaced with this. There's no. This is. There's no part. It says which is this part. 2n. Just 3055. There's no 2n3055 at all in this whole page. I think I'm being hard by somebody who's kind of, you know. Okay, what is this? Here, 2n3055 is a transistor. 2n3055 is a transistor. So, uh-huh. Capacitors somebody has accessed themselves to. I have only capacitors. Okay, we'll make do with this. So how much does a transistor generate? We'll see. How much does a transistor generate? How much current does a transistor generate? Okay. This is, I have no background in this. It's really hard for me to understand. It's not good. I will see with picofarad itself. So I have 470. So this is twice. So how many volts is this? Let me go back to my calculation. All right. Please bear with me. We are in this together. We could be isolating the RNA molecule. P equals VI. Huh. Maybe this is a roundabout way, but I have to generate the waves, X-rays. So that was, V equals L di by dt. So 10 power minus 6. There is no hope of, I'm getting more. What would it be if I were to have 470 multiplied by 2 is about close to 1,000. 1,000. 1,000. And this is 1,000. 2,000. 2,000 microfarad. 100 microfarad. 200. So so I'm going to see this. All right. So this would be, what waves would I? I have no idea. Maybe 10 power minus 6 would would take me to a higher power range. will take me to a higher frequency. So that would be 10 power 20. What waves do I generate at 10 power 20? Let's see. Frequency of frequency of 10, because I don't have the picofarad. Somebody has helped themselves to it. 20, and what frequency and what rays do I generate? 10 power 20, some color. All right, we are in for a treat. We'll just I don't think gamma rays. Okay, the gamma rays, not good. Gamma rays are not harmful. Are gamma rays harmful? Are gamma rays dangerous? Oh, with regards to gamma rays are not good. Gamma rays are not good. No. Transistor. It's getting harder and harder. Somebody's helped themselves to my picofarad. You can't leave anything at home these days. It's not my husband or my son. See, okay, we're going to go back to my calculation. See, what could I do? How about current? Current square. So I'm connecting 4 batteries. That's not battery, 4 picofarad. So I'm so close. I'm so close. Okay, I wouldn't be generating that. These could be. Do these look like picofarads? Resistor. $15 on this. These look like picofarads? They're not picofarads. Picofarad. The lettering's erased. Does it look like pico? Let's see if I can see with the. Give me a minute, please. I'll get a magnifying glass and see if the lettering's being erased. Maybe this is the picofarad. It's been erased. Gamma rays are not good. Gamma rays are not good. Okay, let's see if I get a blue light. Okay, this is no good. This is not good. Blue light. All right, blue light. That's for the chair of the Department of Chemical Engineering and Applied Chemistry in the University of Toronto. He says, let there be the blue light. But then Canada's all red. Or maybe, but we mustn't get too greedy. All right, blue light, sun. So there is a sun in my life. So maybe I generate the blue light. So this is all the RNA molecule. Nobody knows what James Watson and Francis Crick saw. Blue light wavelength, frequency, we'll see. All right, frequency of blue light. Maybe, it could be a conspiracy from X-ray diffraction analytical equipment makers. And that might be it. All right, excuse me. So this is 6. Oh, this is even lower. I beg your pardon. All right. So a plan changed. What am I going to do? I'm going to substitute the Einsteinian equation, mc squared. And that might get me, because Planck is not doing it for me. Planck has no value for a woman in his life. Let's see Einstein. What does he do? I told you, right? Einstein had said triple X for a matrix, triple X for a matrix, and that was also a null matrix or something. Null matrix. So quickly, while you're watching, so energy P, so A equals some H star nu. So we'll take this. So mass of electrons. So we're going to generate a mass of electrons only. So somehow C does not go away, because electronic scared. So light. So no Swarovski crystal at all. So E equals energy by time is equal to power. Oh, so somebody knocked on the equals power and is equal to m star c square. So the time gets cancelled, m star c square. So is equal to, so that's a resistor. So C star L square. So di by dt square is 4. I'm going to use 4 batteries plus 3600. Okay. So I integrated, etc. All right, basic integration. So not a complex piece of calculation. So mc squared. So how much of mass of electron? Oh my God, this mass of electrons I have to generate is so. No, it's not coming. It's not easy. So how about but I have to show you something. I have to, because I wasted so much of your time. So I have to show you something. Mass visible 10 power 14. This is even what is not dangerous. We'll see. What is not dangerous is not dangerous, and is of the order of 10 power 20 hertz frequency. So Google's thinking. Oh, it crashed. I think the system crashed. Gamma rays. Dangerous. Photons. Supernova or blazes. All right. Cosmic gamma ray background. So this is, but it's really far away from us. I would be right in the eye of the um, gamma radiation ionizing. Hmm. Show you something. So somebody stolen my picofarad. I shouldn't have. So M star. So this would be getting 20. So resistor. That's all set up. Diodes. What do diodes do? Diode, I've studied all this, but I have a book also, Semiconductors. It's a losing battle, isn't it? This somebody has stolen my picofarad. These are, these are, we just connect all resistors. So it's got to connect all capacitors. So this is. Let's see. Should have taken a break. Should have worked right away. Should have worked right away. So this it's not possible to bring in Einsteinian equation. Planck says he's going to get offended if I were to. So I'm going to connect all my capacitors to this. I don't like people doing this. Then, you get scared. So we are going to. Okay, let me try to think. So I need a small, so high. So 10 power minus 12. So then I would generate 10 power minus 12 picofarad. So this is done. This is done. This could be picofarad, right? I'm coming out with microfarads. I have these magical equations which would, allow me to calculate. It's all with Professor Allen, LinkedIn. I don't have access to my own work. It's just not a fair world. I'm doing poorly on this. How about I sign out, come back part two, because then that way I can think carefully. All right, signing out. We'll be back soon, so that might be good. I'm not running out the camera.